What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to have a look at how to find the gradient and the y-intercept of any linear relationship. With these two bits of information, we can draw anything that we are ever asked in a test, and the two skills that we need to learn are actually pretty simple. So there are only two things that we need to look for in a linear relationship. The first thing is, where does this thing start? And just remember, when I use the word start, I don't mean at the beginning. Linear relationships actually go forever. But what I am talking about is, where does this thing cross the y-intercept? Or what is y equal to when x is 0? Then the other thing we need to look at is, what is the pattern? And what I mean by pattern is, how does y change every time x goes up by 1? So as x increases, what's the pattern? What's the recurring thing that happens with our graph to make it a straight line? So the formula that you're going to see for linear relationships is that y is equal to the pattern, what's happening, multiplied by x, plus the start value, whatever we start at. And with these two bits of information, we could always project what's going to happen in the future or what's going to happen in the past. The fancy word for the pattern is the gradient. So that's what we're looking for, the gradient. And the start value is that y-intercept, or what y is equal to when x is 0. Just as a really big point of emphasis here, see how the y is there by itself? That's the thing that we are looking for. That's what is changing. The start tells you whereabouts on the y-axis we are when x is equal to 0. And then the pattern tells you how y changes. So both of these things are looking at what's happening to y at any point during our graph. Just to be really clear, the start is the y-intercept, and what the y-intercept means is it's when our line crosses over the y-axis. So wherever there's a vertical line and you see a linear relationship exactly cross through at that point, that's what the y-intercept is going to be. Because we're only looking at the y-axis, we are looking at when x is equal to 0. Anytime you move off that y-axis, x isn't 0 anymore. So because we're just looking right up and down that axis, x is always going to be equal to 0 for every single one of these questions. So we're going to look at an example here on this pretty shoddily made graph. So let's just look at this blue line that I've put through here. It's got a negative gradient, it's going downhill, but the important bit that we're looking at is that it crosses the y-axis at y is equal to positive 2. So for that reason, we know that the coordinate of the y-intercept is going to be 0, because that's what x is equal to, and 2, because that's where the y-intercept is. That's the crossing over point. This is exactly the same y-intercept as this green line. These two things look completely different. The blue line's going down, the green line's going up, but they cross the y-intercept at the same position. So in our language that we've been using, that's the start, but all we need to know is that when x is equal to 0, both of these lines are at exactly 2. Then just to hammer this home, this black line has a less steep gradient than the green line, but again, it's crossing the y-intercept at that y equals 2 point. So all of these three things have the same y-intercept, but look completely different. But it's really important that we know where they cross over. And we also don't have to have lines that cross over in the positive direction. We can have a negative y-intercept if the line crosses on the negative side. So this line here has a y-intercept of -3. So the coordinate of that y-intercept is 0, -3. So just a couple of things to remember as we talk about the y-intercept. Every single place on the y-axis, doesn't matter how far up you go or how far down you go, every single position on that axis, x is definitely equal to 0 all the time. So this means that we can just always put 0 into an equation because we know that that's what the y-intercept is going to give us. And we're going to see how we can work that out in just a few minutes. The second thing we saw, that the y-intercept does not change based on the y and x values, right? Based on the gradient. It really doesn't matter. All of those ones before went through at 0, 2, the same y-intercept, but they looked completely different. For this reason, it means that the y-intercept is what we call a constant thing. It kind of stays the same, no matter how that gradient changes. For this reason, because it's constant, it is a constant term, which means it doesn't have a letter with it when we write it down in our mathematical equation. The best thing about the y-intercept is it's super easy to find these in the graph. You just look at where it crosses that big line that goes through the middle. And it's also really easy to find in an equation form as well, because we're able to do some really easy multiplication with 0. So let's have a look at this first equation. We've got y is equal to 4x plus 5. And if I asked you to find the y-intercept, you might be a little bit confused, but the major key point that we have is that we know for sure that x is going to be equal to 0 because it's somewhere on this y-axis. So all I've got to do is substitute x is equal to 0 or a 0 into this equation and work it out. So if I put 4 times 0 plus 5, well then the answer is y is equal to 5. I do just have to remember that this is a point, not just a one-letter answer. So my y-intercept coordinate is 0, 5. It's the exact same when we have negatives around. I know for sure that x is going to be equal to 0 anywhere on this y-axis. So if I throw a 0 in there, I've got minus 3 times by 0, that's 0, and negative 6 is left over. So y is equal to negative 6. That means my coordinate is 0, negative 6. So instead of substituting in 0 every single time, you can actually just cover up the first bit with the x. Whatever's at the end, that's the y-intercept. Finally, it doesn't even matter if it looks different. Y is equal to 8 plus 7x. If I substitute 0 into this, I've got 8 plus 7 times 0. So y is equal to 8. This means that the y-intercept is 0, 8. So whatever the constant term is, that's the y-intercept. The only thing that we do definitely need to know is that the y has to be on the other side by itself. If the y is hanging out by itself, we can substitute 0 in. We're definitely going to get the right answer. The other thing that we're going to be asked to look for is the gradient. And that's the pattern that happens over and over again with these linear relationships. So this is saying, hey, how does y change if I change x by a certain value? Obviously, it matters what it starts at, that's the y-intercept, but now we're just looking at the recurring pattern that happens over and over again, and there's another really easy way to find that, just by looking at our equation. So what we're going to look at here is that y is equal to 3x, and we're going to see if we can find the pattern. All we're going to do is change x by 1 every single time, and see what the change in y is as a result of that. So if I substitute 0 in here, I've got 3 times 0. That makes y equal to 0. If I just throw 0 in there, I know I've got a point at x is equal to 0, y is equal to 0. This is the origin. Now if I increase x by 1, instead of having 0, I'm now at 1. What's the resulting change in y? I can substitute in x is equal to 1 into this equation. So y is equal to 3 times 1, and that's equal to 3. Now we could probably just go, ooh, looks like the pattern's plus 3, but let's just double check. Now if I increase x by 1 more, x is equal to 2. If I substitute that into y is equal to 3 times 2, well, y has to be equal to 6. Now we can see that the pattern is going up by 3. Y is increasing by 3 every time I increase x by 1. And this will work even if I go backwards. So if I make x negative 1, or if I take 1 away, all that's happening is that y is equal to 3 multiplied by negative 1, which is equal to negative 3, and this still fits in my pattern. Finally, sub in negative 2, 3 times negative 2 is negative 6, and this looks like a perfectly straight line. We can see here that the pattern is plus 3 every single time. That plus 3 is important because it comes from y is equal to 3 times x. So the pattern or the gradient is just equal to 3. So the gradient is super easy to find. It's just whatever term is with that x value. Again, we just have to make sure that we have y on the other side, and that y has to be by itself. It's kind of like we're trying to find an unknown with our equation knowledge, but we have y by itself instead of some other value. So if y is equal to something times x, that something is always the gradient. That is the pattern that is repeating itself over and over and over. So the only thing that you're going to be asked to do in a test condition is to put these two skills together. Hey, from an equation, what's the gradient? What's the y-intercept? If you can just look at the letters in front of you, you're going to be absolutely fine. So this one here is y is equal to 2x plus 3. Well, the pattern is just whatever's with x. So that means that the gradient is equal to 2. And that starting value, the start of the pattern, is plus 3. That's just the end thing. I subbed in x is equal to 0, but you can just cover it up with your thumb. Whatever's there by itself is the y-intercept. So the next one here is negative 4x plus 7. So the gradient here is just negative 4. That's what's with the x value. And then the y-intercept is just equal to 7. That's what's by itself. That's the constant term. So what this is saying in less mathematical terms and just kind of talking about it is that y is going down by 4 every time x goes up by 1. But we also know that when x is equal to 0, or when the line crosses the y-axis, we're definitely going to be up 7 positions. So it's going to be quite a high up number that's still going downhill. And it doesn't even matter if we don't have a whole number with that x. This here is y is equal to 2 over 3x minus 6. The gradient is just the number with x, 2 over 3. That is totally fine. All that's saying that is every time x goes up by 1, y goes up 2/3. So it's not going to be as steep of a graph. It's going to be a little bit less. The y-intercept here is that -6, and the negative there is important. You do always have to remember it. But really, this is exactly the same. What numbers with x? What numbers by itself? Write them both down. So this last one looks a little bit different. We've got 2y is equal to 4x plus 6. And it's really easy to be like, oh, well, the gradient's 4. I know that straight away. But we just have to make sure that the y there is by itself. 2y is not the same as y. So what I'm going to do is divide every single thing here by 2, just to get that y by itself. That means that I've got y is equal to 2x plus 3. And now this looks exactly the same as the forms before. So this means that the gradient is 2 and the y-intercept is 3, and that's all we've got to do. So the hard bit about this is just making sure that y is by itself, and then I divided both sides by 2 because it was 2 times y, and I had to do the opposite operation to make sure that that letter, that unknown, was by itself. Thanks so much for watching this lesson, guys, and I'll see you later.